Here's an example video for the topic Writing and Evaluating a Function Modeling Continuous Exponential Growth or Decay given doubling time or half-life. In this video we look at this problem. A specific radioactive substance follows a continuous exponential decay model. It has a half-life of 18 hours. At the start of the experiment, 489.7 grams is present. Now for part A, they wanted us to write the formula relating y to t. And we've already done this here, assuming that we've already done our math. And we get y equals 489.7 e to the natural log of 1/2 over 18 times t. Now, our goal for this video is to show how to solve part B and properly type it in the calculator so we can get the answer correct. Part B wants us to figure out how much will be present in 21 hours. Do not round any intermediate computations and round your answer to the nearest tenth. So what we're doing here is we'll be typing this in the calculator and plugging 21 in for t. Now intermediate computations, that means, let's say we split up the problem, like we first solve e to the natural log of 1/2 over 18 times 21, and then we multiply that by 489.7, which actually is an effective way to do it in the calculator. Because sometimes if we type the entire thing in the calculator, we might type the wrong thing, or it won't get the order of operations correctly, and the answer can come out incorrectly. And it appears that many students have had this problem with this calculator and this kind of problem because it can be pretty difficult to type that in a calculator. So we will break it apart and start with e, and then we'll do this to the natural log by clicking natural log of 1 over 2, and then on the keyboard type the right arrow twice to move it out of the natural log, and then divide that by 18. And then you click the right arrow again on the keyboard to go outside of that, and then click the multiplication symbol times 21 for t. So e to the natural log of 1/2 over 18 times 21, and then click equals. Now we're not going to round this or anything, we're going to leave that and multiply that by 489.7, which is what we had left in here. And then s equals 218.1365514. So this is where we're going to round our answer to the nearest tenth, 218.1. So we get 218.1 grams, it's our final answer, using this equation that we'd already solved for.